then let's start. Welcome to the talk about mastering Unity Catalog and some lessons that we learned at Zalando during the adoption. Yeah, first of all, who I am, I'm Sebastian Harold. I work as a senior principal engineer at Zalando. I'm with Zalando six years. I also worked in ML productivity, streaming data warehouses, and mainly in data platform. Yeah, so who is Zalando? Zalando is the leading multi-brand fashion destination in Europe. So we are the biggest fashion retailer all over Europe. We are not in the US yet, but in Europe we have about 50 million customers and make revenue and all of it. And of course, we are also a big Databricks customer. So we have almost 1,000 monthly active users. We have over 300 teams in Zalando using Databricks on a monthly basis. And we have, in average, about 15,000 jobs per day. So we are using Databricks a lot. Yeah, what about Unity Catalog? So maybe, how many of you have already adopted Unity Catalog in your setup? Maybe can you show your hand? Okay, yeah, pretty much so. Cool. I maybe first start with our motivation. Why do we want to use Unity Catalog? What we felt is that Unity Catalog became the center of innovation at Databricks, right? So all the Lakehouse IQ, LLM training, serverless, Databricks SQL warehouse, system tables, everything new happens around Unity Catalog. An additional motivation was that we wanted to have one central catalog where all the data is available. So currently we have more than 200 technical data catalogs, so you will see that later. But having one big technical data catalog has much more transparency for the teams and enables a much better data discoverability. If you want to look for data, you just go to this one technical data catalog, which is Unity Catalog, and that's it. And in our case, it would also make it much easier for data sharing because we share tables instead of S3 paths, what we currently do. Another motivation was that Unity Catalog enables fine-grained data access control. This is what we lacked from also a compliance perspective. So we want to have column-level security, we want to have row-level security, and with that, we want to have automatic access provisioning to make it frictionless for the users to get access to data because they shouldn't wait long to get access. And also we want to integrate with our scalable data access control program, which is rolled out for all major data stores. Maybe just short excursion what the scalable data access control program is. We call it SDAC. So whenever I say SDAC, I mean this data access control program. So the main idea of SDAC is that the team is a security boundary. So every data that is owned by a team and the team have access to can be shared within the team without any control. So the data that the team has access to can be shared within the team, but we want to be involved if teams share data with other teams. Yeah, because then maybe there's another purpose, and we want to intercept this and ensure that this happens in a compliant way. And so the Scalable Data Access Control Program is not only rolled out for Databricks, but for all major data systems, which is also BigQuery or Redshift or Trino, and we also want to adopt it for Databricks. What it already enforces is column-level security. So we need to, especially for PII data, if there's customer email addresses or customer names involved in tables. Many analytical use cases don't need that. so that we need to filter them out. And we also need row-level security, and this is mainly driven from antitrust regulations or consent management, that certain users are not allowed to see certain partner data or other stuff. That's why we also need row-level security. And what we have with Aztec is automatic data classification. So sample data is processed and classified, so that we automatically detect, okay, here's the username, here's the address, here's a customer ID that maybe is classified as well. This happens automatically. And the cool thing is that with having this fine-grained access control, we can simplify processes of getting access to non-critical data. So if you only need to read the non-sensitive data or part of a table, then we can grant you immediately access to this table as long as you don't read the username and whatever, and the user email address and so on. So this simplifies our processes and speeds up the access to data. Okay, short excursion. Another motivation was that with Unity Catalog, the access control happens at the catalog level, not anymore on S3 level or on cluster level that we had before. So people can just easily switch clusters, and the same person has access to the same data on any cluster, which is nice, right? So you can have these all-purpose clusters, you can have team clusters that are shared. The same person has access to the same data, independent of which cluster the person uses. And so you can also centralize clusters that are running 24/7, and this is compliant because Unity Catalog enforces the access control. So what were the basic design principles for our Unity Catalog adoption? First of all, we wanted to make everything full self-service. So all the common actions that you need should be done autonomously without interacting with any central team. So people should just self-service, create their team catalogs, for example, create their tables, create their robot users in a compliant manner. So that's why another principle was security by design. Yeah? So we need to ensure that we are not reactive, we want to be proactive. So we want to make the design compliant from the first minute on. So that this means, for example, that all the data sharing between teams is only possible via the central processes from Aztec. And lastly, we want to make it simple to adopt Unity Catalog by having predefined templates. So all the major functions are available as ready-to-be-used components, and they can be deployed via CI/CD, so that users, if there is not a problem, can just go to Unity Catalog in a few minutes, without asking anyone or whatever. So, okay, then it's simple. So there are only 3 questions. Yeah? How do we structure Unity Catalog? How do we map our security model to it? And the last question is, how do we migrate our current model to the new model? Yeah? That's it. But you will see that these questions are not as simple as it looks, and this is what I will talk about. Maybe short recap on the Unity Catalog structures, on how it works. So first of all, you have we are on AWS, but for Azure and GCP, it's quite similar. You have one metastore per region. And in this metastore, you can have multiple catalogs. And the catalogs contain the schemas, the tables, the views, and so on. All these are in a catalog. And then there are tables, and the tables are actually mapping to files on S3, right? So there's the physical data is still on S3. And this is done via external locations. Yeah? So external locations are kind of the map through for the S3 parse. And then the external locations, or the access to external locations is managed via storage credentials. And storage credentials are the link to the actual AWS IAM role, which gives Databricks physical access to your data. And these AWS IAM roles, they trust the AWS account from Databricks to have the access, but this is all managed behind the scenes in the appliance of Databricks. So we need to somehow fit or find a model that fits into this structure. Where we are coming from, currently we have a super cluster-centric approach. So we have these cluster configs or cluster definitions, you could say, and the cluster config contains everything that is important for the cluster. So who has access to it, so all the users and robot users, the sizing of the cluster, so how many nodes, what is the instance type of the nodes and stuff like this. Also which libraries are installed at startup time, and all the access to, for example, S3, but also to other AWS resources is defined in one single JSON file that sits in a central GitHub repository. So for each team, or some teams have multiple cluster definitions, there's a central repository. They can make a pull request to do changes. And so we have half self-service methodology here through pull requests. Yeah, and what is important, also each cluster is owned by a team, right? So also for cost attribution and having contact details. So what works well in the current setup? So the cool thing is that for each cluster, you have the whole config in one place, which is, you have a good overview. Also, you have the central GitHub repository so that you can easily see how many people are using, for example, a certain library or S3 parse or whatever. And the cool thing is also that teams have independent clusters. So you don't have the problem of noisy neighbors. Each team has an isolated cluster with own permissions, own configurations. And other teams are not interfering with this cluster, which is nice. The people can trigger the changes, and they can start the clusters or jobs on their own, so they are kind of independent, which speeds them up at the end. Yeah. Also, one implementation detail is that each cluster has its own Hive Metastore. So we started with it because of version compatibility issues with Hive at the beginning, so we are using Databricks quite a long time. But this also ended up with having over 200 Hive Metastores, which are partly overlapping because people create external tables on S3 data multiple times in different Hive Metastores. And so what do we lack? There is a little waiting time because all the changes need to be approved by the central team, which is not fully self-service, but it's okay. And because currently we give access on S3 level, we don't have column level and row level security at all. This is what we definitely want to improve with Unity Catalog. And currently it's hard to use these central clusters because we give access on the cluster level. So we cannot share cluster easily because people would get not individual data access, they would get the access of the cluster, and this is probably not compliant. The consequence is that people have their own clusters, but this always takes 10 minutes or 8 minutes to start up. So people start their Databricks cluster, grab a coffee, come back, and file the first query. So this is quite annoying for the teams, and we also try to overcome this with Unity Catalog. So what will the catalog model look like? Yeah? So in theory, it's super easy, right? So before we have these individual Hive Metastores, the Hive Metastores, they have schemas, the schemas contain tables, and so on. So we could easily translate this into, yeah, we have this big Metastore, And then we have just, for each Hive Metastore, we have now a catalog. Yeah? And then you have these schemas in there and the tables. So sounds like an easy migration. So why are we not done yet? Yeah? So if it's so easy, what is the problem? And we found several challenges that made the migration a little bit more complex. So first of all, the problem is that currently in Databricks, the owner of the data is quite powerful. And what the owner, so if you create a table, what you can do as the owner, you can grant other people access to this data. And this is actually what Aztec tries to avoid. We want to have, for data sharing, especially between teams, we want to have this process in the middle that ensures that compliance. So because the compliance rules are so complex, we don't want that every data owner really goes deeply into what is a PII column, what rows I need to filter on, and so on. So this is centrally done by the experts. And so we needed to overcome this problem. And we saw three major options. So the first option was we can go reactive. So we could run, let's say, a monitoring job which checks the audit logs regularly and checks if there are any unauthorized grants. The problem is that you're always reactive. So there is a short time period where the access would be granted, and then maybe you find this unauthorized access, and then you can remove it. But it's not nice, right? So people would get access for a short time period. So we prefer to have security by design, which brings us to the second option, is that we don't give access to the tables directly, but we introduce dynamic views that we own centrally, and we put them in a shared, we call it shared catalog. And they are under control, and access is only granted on these dynamic views. And the third option, I think Todd will talk about it from Databricks, is to wait for the new policy framework, which will probably arrive next year somewhere. And with this framework, you can hopefully also overcome this limitation. But for now, we are going for option 2. So what does it mean? So you have this model, and what we need is, we need to introduce kind of we call it shared catalog, which is owned by our central team. And in the shared catalog, you have a schema per team catalog. So here, schema A belongs to, or corresponds to catalog A, and schema B corresponds to catalog B. And in these schemas, you have dynamic views for all the tables that are shared across the company. The cool thing is that the dynamic views do all the row level and column level security behind the scenes. And we can, with the Aztec integration, we can update it and have a compliance data access framework. So what does it look like? So I think, yeah, the table name doesn't match here, but you can create these views. And if there are non-PII columns, you can just select them directly. But if there is a PII column, in this case, the PII column is the email address, you only can see it if you are a member of this account group called sales order PII. And if you're not a member of this group, you will just get null values for the email address. And similarly, you see it in the where condition. So all the members of the sales orders all group, they can read all the rows. Otherwise, there will be a filter on a certain column. In this case, for example, the merchant ID is Zalando, which means these are only Zalando wholesale orders. There's no partner data for no partner sales is included. Because only certain people can see all the partner orders as well. Right? And we would generate these views behind the scenes. We own it, so we are the owner and grant access to it. And we have kind of a publication workflow where people can say, I would like to share a certain table, and then the dynamic view is automatically generated, and people can use our central catalog to get access to it. Yeah. Another challenge for our migration to Unity Catalog is Unity Catalog allows only one external table pointing to the same S3 path. So the problem is that currently we have multiple independent Hive Metastores, and people can create external tables pointing to the same S3 path, which is no problem. But if you go to Unity Catalog, this doesn't work anymore. So Unity Catalog will complain if there is a second, or if you want to create a second external table pointing to a location which is already registered to another external table. Yeah? So here in this example, table 4 could be created to point to a certain S3 bucket or a certain S3 location. But if the other team wants to create an external table also pointing to this location, it will fail. It will not work. So what do we do is they can introduce views. Yeah? So because data sharing is anyway centrally handled via the shared catalog, there is this owner. The owner owns the table, which or the external table that points to the S3 location. But all the consumers, they can create, if they want to keep the code compatible, they can create views in their catalog pointing to our dynamic view, and then they don't need to change the code, and it works. The problem is this somehow creates dependencies between consumers and producers. So what we try to do is we want to push the major data owners to be the first adopters so that all the others can use these tables already. But this is a little bit friction in migration, especially at our scale. Okay, last challenge is currently we use instance profiles or AWS IAM roles to give access to S3. And imagine you have a data producer, yeah, which is still in this old IAM role instance profile world. And this data producer puts the data in writes to S3 bucket, and then there are two data consumers. One is also still an instance profile, but one consumer already adopted Unity Catalog. So if the data producer also wants to adopt Unity Catalog, he would create a Unity Catalog table, and now the ETL job for the data consumer 1, which is on Unity Catalog, would break. Yeah? Because the job cluster for the data consumer 1 would immediately try to use the Unity Catalog permissions. And if the permissions are not set, the access would grant. So this would create really a high dependency between teams during the migration. So people need to be really careful if they create a Unity Catalog table, because it could immediately break all the downstream consumers, which is really tricky to handle at large scale with 300 teams, what we are talking of. So the idea here is, this is a new feature. I think it will be delivered in Q2, which is called fallback mode. This is a cool idea. So you can activate fallback mode on an external location. And if you create a Unity Catalog in this external location, and someone with a Unity Catalog enabled tried to read this table, then the first thing the algorithm does is it tries to check whether you have permissions on Unity Catalog to read the table. But if it does not work, it still goes back to your AWS IAM role instance profile thing and checks where you can directly read the table. So this would decouple the team's migration and removes the dependency. So this is a pretty cool feature. that we develop with Databricks to overcome this migration at scale problem. Yeah. Last challenge is currently people also have access to other AWS services from their Databricks clusters. Could be DynamoDB, this could be SNS, SQS, other AWS services. And this can be done by just assuming a role, because everything is AWS integrated, it works well. So if there is a team A and a team B, they can access their AWS services totally independent. The problem is, what we cannot do is we cannot let them use a shared cluster currently, because either they would share the access to the AWS services, or we have to deny it. So we cannot use these shared clusters easily without having individual AWS credentials. And the solution, I think it's in preview since 2 days or whatever, is there is a new feature called Cloud Service Credentials, which solves the problem. So you can kind of have an AWS role assigned to Cloud Service Credentials. Cloud Service Credentials are a Unity Catalog feature, so you can grant access to this kind of entity. And we can create 2 AWS or Cloud Service Credentials, one for each team, and we can say that the users from Team A can only access the Cloud Service Credentials for Team A, and Team B only can access the Cloud Service Credentials for Team B. So they can use a shared cluster, but still have the individual access to AWS resources, which is quite cool. Okay, then let's summarize the new catalog model. First of all, what is important is users can create the resources totally in isolation, full self-service, so all the catalogs, external locations, service principals. What we used for this is AWS Service Catalog. So we have built AWS Service Catalog products so that they are easily deployable via CloudFormation or directly via console. And all the actions and validation is happening behind the scenes with our back-end services. What is important is the catalog is always owned by a team, right? So we want to have data ownership, we want to enforce that. So each catalog has a team assigned. And there's this special shared catalog where all the shared data sets are in. So people can also easily discover that. So if they are looking for data, they first go to the shared catalog and see what other people are exposing, and hopefully this is enough for their use case, and can get access via this SDAC process. And inside the shared catalog, there are these dynamic views pointing to the source table, and the dynamic views are also handling the whole column level and row level security. And lastly, the cloud service credentials allow access to AWS resources even on shared clusters, which is pretty cool. So we know what the new model is. The question is, how do we transform our current model to the new model? And for the migration path, we had some basic principles because our migration is so complex. First of all, we want to leverage Unity Catalog for people or for teams that are curious and want to adopt Unity Catalog as fast as possible. Yeah? All this data lineage, all this fine-grained access control, we want to leverage to boost the productivity and security for our system. But there are so many teams involved. Some of them have other priorities or have a different speed of adoption because maybe they have more jobs to adopt and it's more complex. So what was important is that people can migrate in isolation, yeah? and try to avoid dependencies between teams during the migration as much as possible. So we want to have little to no dependencies to other teams so that each team can have its own speed of migration. And lastly, we want to keep the effort for the teams low. So we prefer to automate things centrally and maybe have more central effort at our team. But if it speeds up the migration because the teams have less effort, then we always prefer this. Okay, so let's make an example, right? So the team that wants to adopt Unity Catalog is in the middle, yeah? So it's the data producer, and it still uses instance profiles. And the problem is we have such a complex migration, you have all possible combinations during the migration phase, right? So you have the data sources, data source A is still on instance profile, data source B is already available as Unity Catalog table, and also on the consumer side, yeah, from the data product that the data producer is producing, there's data consumer 1, which is already using Unity Catalog, and there's data consumer B, which is a little bit slower. It still uses these instance profiles to get access. So now the data producer wants to use Unity Catalog. How does it look like? So first of all, what they need to do is, before they create Unity Catalog tables for the data producer, they need to activate this fallback mode. So fallback mode ensures that all the downstream consumers don't have broken pipelines when you create Unity Catalog tables. So this is the first step that you do. You activate the fallback mode, and then you can also activate Unity Catalog for this table because everything stays as before. The next thing that you do is you create the Unity Catalog table, and because of this fallback mode, all the consumers still consume the data as before, but you can start using Unity Catalog as a data producer. So, and then the next thing is the data consumer 1 gets access to the Unity Catalog table via the SDAC process. And the other consumer still reads the data over instance profiles, but now you use the SDAC process to give access and use Unity Catalog row level and column level security. And yeah, finally, you can deactivate the fallback mode so you can deactivate the fallback mode in case all the consumers that you have already use Unity Catalog. Yeah, so you can check this from the S3 audit logs or whatever. So whenever you see that all your consumers are using Unity Catalog, you are done. You can deactivate the fallback mode, and new users always need to use Unity Catalog, which is great. And so if you are finished with the migration, you can deactivate fallback mode in general, so all the data sources and the data producers, the data consumers are on Unity Catalog. So this is where we want to get. Yeah? So then you don't need this anymore, and all new use cases use Unity Catalog automatically. Okay, so what is the status? Yeah, we are not done yet, and it will still be a long way. Some of the features are still in preview, so we are a little bit shy to use them in production. We started with the pilot team already, so this looks good. The self-service deployment with AWS Service Catalog as the, let's say, deployment helper, this is already ready. We are currently working on the SDAC integration to be finished. And next thing is also push the major data producers to use Unity Catalog so that for the data consumers, it's much easier to adopt this. So we think the whole migration will probably take multiple quarters because of the complexity of our project. But yeah, so we we're glad that we, together with Databricks, found these solutions, and yeah, so we are ready to go and motivated to execute. Yeah, so yeah, big thanks for the Zalando team. Yeah, so I'm just one of the representatives here. So there's Hiroki, Dejan, Pavel, Aruba, Stefan, Aykut, who is also in the room here. Big thanks to the team for all the support. And of course also for Databricks. We are closely collaborating with the product team, but also Marcin as a solution architect, Ivan, and also Mareike and Luba for the whole support, and yeah, for endless support sessions that we had. Yeah. I think that's it from my side. Thank you.